Okay, in this lesson we will be writing linear equations given a table, graph, or verbal description. Once again, a linear equation in two variables is a relationship with a constant rate of change represented by a graph that forms a straight line. Real quick, let's go back over the various forms of linear equations. We either have slope-intercept form of y equals mx plus b, the form that we're used to, where once again m represents our slope or our rate of change, b is our y-intercept. Once again, let's talk about that y-intercept. That y-intercept is when your x equals 0 and you get some y value b. Okay, point slope form, y minus y1 equals m times x minus x1. Once again, where m is your slope and x1, y1 is a given point. Once again, that x1, y1 is just naming the points. And then lastly, we got our standard form of ax plus by equals c, where a, b, and c have to be an integer. Once again, integer means -3, -2, -1, 0, 1, 2, 3. Not a fraction, not a decimal, in the sense of what y'all are used to. And a has to be greater than or equal to 0. Once again, a cannot be a negative number. And your x and y terms are on one side of the equation. Okay. And once again, our different various methods of finding our slope. We've done this in other lessons, but once again, changing y values over your changing x values. Y2 minus y1 over x2 minus x1. If you're given a graph, you can do slope equals rise over run. Algebraically, if you've already got rid of slope, if you've already got rid in slope-intercept form or point slope form, you're pretty much given the slope if you just look at the value of the number in front of the variable x. And it's not always going to be x, but just in front of that variable. Okay. Some sample problems if you want to go over. All right. In this question it says, the weight W in pounds of a stack of books is dependent on the number of books B in the stack. So once again, the stack of books is dependent, or the weight is dependent. So of course this is like our y value, the W. It's our dependent. And B is dependent on the number of books. So of course B is our independent, or aka like our x value. This table below represents the weight of 4 different stacks of books. So looking below, we got number of books B, 4 books, 10 pounds, 6 books, 15 pounds, 10 books, 25 pounds, and 16 books, 40 pounds. It wants us to write an equation in point slope, slope-intercept, and standard form in terms of B and W that represent the data in the table. Once again, W is like our Y and B is like our X. So, sure I can see these. We want to write it in point slope form, slope-intercept form, standard form. Well, in order to write a point slope or slope-intercept form, we need to find our slope first. So let's go and find our slope. You can do it a couple of different ways: changing y over changing x, or y2 minus y1 over x2 minus x1. Let's do both routes just so we get a little bit of practice. So changing y over changing x. Let's go with that one first. And essentially it's the same thing. It really is. But just to show you, 10 to 15, that's like plus 5, right? So that's our change in y, or our change in w in this case. Let's not forget to use those terms in a second. And 4 to 6, our change in x value is plus 2. So 5 over 2. Again, it didn't matter which points I went from. If I went 15 to 25, that'd be plus 10. But 6 to 10 would be plus 4. And if you find 5 divided by 2 is, well, like 2.5, I'll keep it as 5 over 2. Or if you did 10 over 4, changing y over changing x, you get 10 over 4. But if you simplify that fraction, you get 5 over 2 still. So no matter where you go from, you'll still get the same one. Real quick, did say I'd go the other route, just in case you want to go that method. And just practice a lot. I'm going to name this guy right here my x1, y1. Once again, that just means I'm naming the points for formula purposes. And let's name this guy x2, y2. Just in case you want to go that route. So m equals y2 minus y1 over x2 minus x1. Well, once again, plugging in what I called my y2, that's 15, minus my y1, which I called 10, my x2, well, we defined it as 6, and minus my x1, which we said was 4. Once again, just following the formula, y2 minus y1 over x2 minus x1. And once again, you can choose any 2 points that you want. It really doesn't matter at the end of the day. You're going to get the same answer. But 15 minus 10 is 5. And of course, 6 minus 4 is 2. Okay, so real quick, I'm going to write that on the side. M equals 5 over 2, or my slope. Okay, give myself a little bit of room here. Hopefully you got that down. Okay. Now we've got a slope and we got some points. So let's go to point slope form. Once again, if you remember, that's y. Oh, let me give myself some room here. Sorry guys, let's see here. Oh. Okay. Point slope form. I'll write it up here. Remember, that's like y minus y1 equals m times x minus x1. But let's not forget that they want us to write it in terms of b and w, where w is like my y. Real quick, let's remember y. That's the same thing, and this is like our x. We're just renaming the variable. That's all we're doing. It's no big deal. Just instead of calling it y, we'll call it w. So it's like w minus w1 equals m times b minus b1. Once again, that w1, b1, just name it a point. And you can choose any point that you want. I don't care which one you choose. You can choose that 4, 10, the 6, 15, the 10, 25, or that 16, 40. Doesn't matter when you plug it in. It's essentially, you're going to get the same equation. It's the same thing. Yeah, there's 4 different ways we can write it with the points that we're given, but either way is the right answer. I'm going to go with the top one. I usually like choosing the top one, so I'm going to call this my x1, name him the x1, and name him the y1 for right now. So now I got w minus, well, my w1, I'm sorry, not, it always throws me off too. Calling him w1, not calling him y anymore, and this guy b1. Okay, so my w1 is 10, so minus 10 equals, well, we found our slope to be 5 over 2, so instead of saying m, I'm going to say 5 over 2 now, times b minus, well, plug in what I named b1, which is 4, and there we go. There's our equation in point slope form. Now let's take it to slope intercept form. Okay. In order to take it to slope intercept form, we can just use our point slope form that we found and distribute out that slope first. So let me go ahead and go over here, rewrite it. We're going to go slope intercept form over here. Okay. Let me make sure I can still see this. Move up a little. Since I got my equation, give myself some room. Okay, so slope intercept form. I'll rewrite that point slope form that we found. 5 over 2 times b minus 4. Okay. So once again, the first step to solving a slope intercept form, let's take that 5 over 2 and distribute it out to these two guys. So we get w minus 10. We didn't mess with it, so we'll just bring them down. 5 over 2 times b was 5 over 2b. And then positive times a negative will still give me negative. And 5 halves times 4. Well, like I said, my favorite thing to do is take 4 divided by 2, which is 2. And 2 times 5 is 10. But once again, if you need a calculator, just use your calculator. Okay. And lastly, we want to solve for the w just like solving for the y. So, and that'll get us a slope intercept form. Oh, I should have wrote that down here. It's like saying y equals mx plus b. But in this case, it's like w equals mb. It's kind of confusing now, mb plus b, but okay, you get the point, I hope. Once again, just solve for that w. We need to move that negative 10 over, so move that negative 10 over, we need to add 10, do the opposite. But what I do to one side, I must do the other. Let's make sure we get like terms with like terms, constants with constants. Well, bring that w down, didn't mess with them. Negative 10 plus 10, of course, is 0, so those just kill each other. Bring that 5 over 2b down, didn't mess with them. And negative 10 plus 10, well, once again, let's kill each other, so we get plus 0. So this would be our slope-intercept form right there. And then the same as mx plus b, just our b is 0 in this case. Kind of like a proportional relationship if you've gone over that lesson. Well, lastly, we need standard form. Okay, well, let's see here. Standard form, well, I'm going to take what I found in my slope-intercept form. And remember, to get this form, we need it in ax plus by equals c form. So our x and y terms need to be on one side. Remember, a, b, and c have to be integers, and a has to be greater than 0 at the end of the day. So once again, my favorite way to get rid of fractions is just to multiply by that denominator. And since c is the only fraction, I just need to multiply by that denominator of 2. And once again, we're going to multiply every term by 2. So we got 2 times w, which is 2w. And 2 times the 5/2 b. Well, like I said, I love this way because this 2 will just kill the denominator 2 here. So you just left with that 5. So 5b. All right, once again, we got to get the terms on one side. The x and y terms, or in this case, the w and b terms on one side of the equation. So I need to move that term 5b to the other side. In order to take that whole term, that positive 5b, I need to subtract out 5b. Okay, but once again, what I did to one side, I must do to the other. And since these guys are not like terms, we can't combine them together, so we're just going to bring them down. So I got negative 5b plus 2w, because 2w is positive, and 5b minus 5b, well, those kill each other, and we're just left with 0. Okay, still not finished yet, because once again, our a value, negative 5, is not greater than 0, so we need to make them greater than 0. In order to do that, we just need to change the sign to a positive. And the easiest way to do that is just multiply everybody by negative 1. Once again, we're going to multiply everybody by negative 1 so as not to change the equation. Once again, multiplying everybody by negative 1 is just like changing their sign. But negative 1 times a negative 5, well, negative times a negative is a positive. And 1 times 5 is 5, so we get 5b. And that negative 1 times that 2w, well, negative times a positive is a negative. And 1 times 2 is 2w. And of course, take a negative 1 times 0, it doesn't matter, we're still just going to get 0. So there's our standard form of the equation. Okay. So there we go, we got our point slope form up here, our slope intercept form right there, and our standard form right there. All right, I want to show you another quick trick, just in case they just ask you to take its right slope intercept form or ask you to take it a standard form. You could use a calculator if you have a graphing calculator and take some points. And you only need 2 when you're talking about a linear equation. So I don't need them all. I could plug them all in. Let me show you what I'm talking about real quick. Let's go here. I'm going to take these points with me to the calculator. And I know when I go to the calculator, it's a little hard to see sometimes, but let's go ahead and take it there. Okay. Just bringing this over. These are my points. So I'm going to start by hitting this stat button. Once again, it's that button right below the delete. Yeah, I'm kind of moving my picture around near it. I'm going to go ahead and hit stat. Okay, I want to edit. So I'm just going to go ahead and press enter. And I need to clear out some points I had in before. So I'm going to press this up arrow, hit clear, enter. It'll clear out that whole line for me. Once again, I need to clear out the other side. So scroll over to it, press clear, enter. Boom, gone. Okay. Now L1, we're going to plug in our x values, or in this case, our b values. So 4 enter, 6 enter. Once again, I only need 2, but you can go ahead and put them all in if you want. 10 enter, 16 enter. Let's go over to L2 and start putting our y or ak or w values in this case. So 10 enter, 15 enter, 25 enter, and 40 enter. Okay, now that I'm here, I plugged in my values into this little table. Once again, I'm going to hit that stat button. Once again, that one right below delete. So hit stat. Now I need to scroll over, so I'm going to press right, the right button key. Scroll over to calculate. And we're looking for linear equations, so we're looking for the line reg. So I can either scroll down to the line reg or just press 4. Either way, scroll down to 4, press enter, and then we get this. And I just need to make sure everything looks correct, and usually it is. And just hit enter on calculate. Scroll down to calculate, hit enter. And there you go. It gives us y equals 2.5x plus b. Once again, it says a equals, in this case, 2.5. You just plug that in. You get 2.5x plus our b is 0. Plug that in. Okay. Hopefully you can see that, what it's doing. You know, it just gives you the equation y equals ax plus b. Then it gives you the a value. Plug that into the a. Gives you a b value. Just plug it into the equation. And so, like I said, you get y equals 2.5x. Well, how does that compare? Let's go back. Go back to our... Oh, look at that. Remember our slope-intercept form of the equation? We got w equals 5 over 2b. Well, 5 over 2 is like 2.5. So we get the same same thing no matter if you do this algebraically or do it with the calculator. And then from there, you can just find standard form as we did before over here. Okay. Well, hopefully that was a quick trick that you could learn. If you have a graphing calculator, go ahead and use it. All right. This time, the graph of a linear function is shown on the grid. Which equation is best represented by this graph? Okay, well, it looks like all our answer choices are in point slope form. Okay, so we needed, first, let's find our slope. So, because you notice some of these on answer choice A, it has a slope of 7 over 5, B is 7 over 5, C is 5 over 7, and D is 5 over 7. And the reason why I can't just find any given equations because we could have a million different equations because of different points. I mean, we can have an infinite amount of different equations. So I'm going to solve and figure out which one of these it cannot be. So first and foremost, let's find our slope. All right. So once again, to find our slope, let's find 2 good points. I'm going to use rise over run to find my slope this time. Let's see if I can find 2 good points. Once again, to find 2 good points, you want to see where your graph or this guy right there kind of intersects with x and y values. So this guy looks pretty good right there. Let's see if I can find another one down the line. Sometimes it's not the greatest thing. I'm going to go ahead and go right here. It looks good enough. So it looks like we're going to go 1, 2, 3, 4, 5 up. So remember, slope is rise over run when we're doing it graphically. So we went up 5, so it's like saying plus 5. So 5 over our run looks like 1, 2, 3, 4, 5, 6, 7. So our run is going to go into the right 7. So of course going to the right is positive. So positive 7. So our slope is 5 over 7. So in that case, we can go and get rid of A and B because that does not represent 5 over 7. Only C and D do. Now, between C and D, well, this is written in point slope form. So what this one's demonstrating is that we have the point, let's see, it says plus 7, but remember point slope form is y minus y1 equals m times x minus x1. So if it actually says plus a number, it means it's the negative version because minus a negative gives us that plus. So this is being represented by negative 7 comma, and here's our y. So once again, it says plus 2, so negative 2. Okay. And this one is representing the point 7, comma 2. All right, so let's go see if these points actually exist. So negative 7, negative 2. So negative 7, negative 2. Well, I can clearly see my graph does not run through that point. So C doesn't look like a good option. What about D? 7, comma 2. Well, 7, 2. Well, right there. My graph clearly exists at that point right there. So that can represent one of the equations in point slope form. So D is our correct answer choice. Okay. moving on. Once again, and I got another graph. It's asking which linear equation in two variables represents the same relationship. We've got some answer choices in slope-intercept form, and then we got some in standard form. Okay, so hopefully it makes our life easy. We can just get in point-slope form. You can find two good points and use your calculator again, using that stat edit method that I showed you. Or we can go ahead and just find it ourselves using rise over run to find our slope. Not too hard either way. I usually like this way. It's a little bit quicker in my opinion, if you know what you're doing. So, this looks like a pretty good point. Also, notice how it gives me my y-intercept already. My y-intercept is where I cross this axis, or my x is 0. My x is 0 here. We'll talk about that in a second, but let's find our slope. That looks like another good point right there. Okay. So real quick, just so you can see what I'm doing. Looks like to get from this point to that point, we're going to go 1, 2 down. So going our right says 2 down, so it's like representing it with -2 since we went down. Over our run, which is 1, 2, 3 to the right. So of course representing going right is positive, so of course we can rewrite this as -2/3. It's kind of the same thing. I do get asked the question, well coach, what if I went from this point to this point over here? Okay, well it's kind of the same thing. You see here, once again, rise over run. Just give you another example. You can go either way. Well, let's say I start from this point right here at this 3, 2. And go the other one. Well, I'm going to go 1, 2, 3 to the left. Well, that's my run. So, of course, going 3 to the left is like saying negative. It's -3 units. And then I go up 1, 2. So my rise is 2, and I go up, so it's like a +2. Well, same thing, -2/3. So no matter what, you're going to get the same result. Okay, well, if we're going to put this in y equals mx plus b form, or slope-intercept form, now we got y equals our slope of -2/3 x, or -2/3 and then times x. Now I just need my y-intercept. Well, once again, my y-intercept exists where x is 0, right here, and it's the y value, and I can see, well, 0, 4 is a point. So my y-intercept, or my b value, is 4. We can go +4. Okay. So let's see if anything matches up with that. Once again, remember y equals -2/3 x plus 4. Alright, well, f doesn't have the same slope, so he's gone. Problem with g is it doesn't match up with our y-intercept, so he's gone. Alright, so I guess we need to put this in standard form. Well, of course, in order to do that, let's go ahead and look at our fractions in this equation, because we need to make sure all of our a, b, and c are integers. And we can see the only fraction is this -2/3. So in order to get rid of that fraction, we can just multiply by 3. Multiply by that denominator. Easy way to get rid of it. So then 3 times y, 3y equals, and once again, to get rid of it, we got to multiply it by 3, but we got to multiply everybody by 3. That way we keep the equation the same. We're just rewriting the equation. But the values, it's pretty much the same at the end. Once again, I like this way because the 3 right here will kill this denominator of 3. So we're just left with that -2x. And of course, 3 times that +4 becomes +12. Okay, once again, to get in the standard form, we need ax plus by equals c. So I need to move the x term over, this guy right here. So I want to move the whole term over. So in order to move the whole thing to the other side, it's like a number, -2 times x. We just don't know what x is, but let's move that term over. Since he's a -2x, let's go ahead and add 2x. And of course, because what I do to one side, I must do to the other side. Well, x and y aren't like terms, so we're just going to bring those down. So we got a +2x coming down, +3y coming down, so +3y equals, like I said, we just want to get rid of it on that side. And we didn't touch that 12, so we're going to bring them down. Alright, Well, looks like a H matches up. 2x plus 3y equals 12. J, it says 2x minus 3y, so he's gone. All right. Moving on to the last problem that we have here. It's like Xavier plays an online video game that allows him to control many different characters. Each character starts the game with 200 gold coins. So they automatically get 200 gold coins. And then they receives 30 gold coins for each month that passes within the game. If Xavier controls 50, he controls 50 characters, and the number of months passed within the game is represented by X, which function can be used to determine the total number of gold coins that Xavier has collected in the game? Well, they wrote this in function notation. And it's no Y, they wrote A of X, so I guess they're talking the total amount of X, or amount. Alright, so I'm going to write a total amount X equals, well, let's first determine how many gold coins each character gets. Okay, it's very important. They start out with 200 gold coins. That's a given value, just 200. And they receive 30 gold coins, so add 30 gold coins each month. Remember, we're representing each month with the X variable. So 30 each month. Once again, because month 1, they'll get 30 coins. Month 2, 30 more, so 30 times 2, etc., etc., etc. Of course, let's rewrite this. Most people like it with the X terms up front. We write it like that. Okay, but that's for each character. We're trying to find Xavier. Remember, Xavier has 50 characters. So in order to do that, we're going to take how much each character gets. And of course, since he's got 50 of them, he's going to multiply what each character gets by 50. Okay, because once again, gold coins each character gets times the total amount of characters that he has. So, once again, we can rewrite this as 50 times. It doesn't matter which way we multiply. Multiplication is commutative, so we'll multiply in any order. So 50 times 30x plus 200. Okay, looks like H is the correct answer choice here. And if you're asking why this guy's wrong, well, once again, 50 times 30x, once again, we got to remember that each character gets this. And he's got 50 of them. So each of his characters, the total amount of gold times each character. Hope that kind of explains it, clears it up. I don't know if I did the best job doing that, but hopefully so. Anyways, guys, that is today's lesson. If you need any extra help, look at some of the resources or go back over this video. Y'all have a good day.